Hello everyone, myself Professor Chavan. We have started the fourth chapter from our 11th Science CBSE board for our subject physics. Okay. So in the previous lecture we have completed all the laws for the trigonometric calculation of the vector addition. How we can apply the law of triangle, how we can apply the law of parallelogram, and where we have to use the law of the polygon. Okay. So in today's lecture we are going to start the next part from our fourth chapter, that is the projectile motion. Okay, so in this chapter we are going to study the two-dimensional motion, and in that there are two types of motion. The first one is the projectile motion and second one is the circular motion. Okay, in two-dimensional motion it is nothing but the motion of a body in a plane where the two coordinates of the body changes continuously whenever the body is in traveling. Okay, so in that case the first one is the projectile motion. So initially we have studied that when a body is traveling or when a particle is traveling, we come to know that it is changing its both coordinates. If we see one object traveling in any particular direction, then we consider it that its x coordinate is changing. Then if it is traveling, then in that case its y coordinates also changing. Okay, so whenever a body is traveling in a plane, then in that case its two coordinates are changing continuously. First one is the x coordinate and the second one is the y coordinates. Okay, so it is not possible that the motion of a body is in a plane and only there is a change in only one coordinate, because whenever the body is traveling in a plane, then in that case it's both the coordinates are changing, and whatever we are seeing, that is the resultant path of that particular particle, and that resultant part we can resolve into its components. We have studied that the resolution of the vectors. Okay, so accordingly we can resolve that final resultant path into its component also, and from that we can get its separate component along the x direction and along the y directions. Okay, so whenever we throw any object, then in that case if we throw any object in a vertical direction, then what will happen? I am throwing this object in a vertical direction, then what is happening that initially it is having some velocity. Okay, so I am throwing this object with some velocity and it will travel up to some distance until it is having some velocity. Okay, it will cover some height until it is having some velocity, and from that point where its velocity becomes zero, it has no any velocity, from that point it will start its motion in a downward direction. So again in a downward direction what will happen? Its velocity goes on increasing. Okay, from that particular height its velocity goes on increasing and it will fall down on the ground. Okay, so what is happening in that case, that whenever we throw the object in a vertical direction, we are not giving any particular angle of projection for it. We are not giving any projection, like throwing the object like this and throwing the object in a vertical direction. These are the two different phenomenons. Okay, the direction changes here. Throwing the object in this particular vertical direction, it is the different, and throwing the object in this direction, it is the different. These two are different phenomena, because this motion of a body is known as the which type of motion? It is following the straight line path. So this is the linear motion. Okay, this object when I throw vertically upward, then it is following the linear path, it is following the straight line path. So this type of motion is a linear motion. And when I throw this object like this, okay, when I throw this object in a upward direction but not in a vertical direction, okay, so when I throw an object in a upward direction but not in a vertical direction, that object becomes one projectile. Okay, that object becomes one projectile, and motion of the object is known as the projectile motion. Okay, so when we throw an object in an upward direction other than the vertical, then in that case the object becomes a projectile, and that motion of object is known as the projectile motion. We are throwing this object like this. Okay, we are throwing this object like this. So in that case we are throwing this object in a vertical direction but not in a vertically straight line direction, but upward direction, but not in a vertical direction. So this is the upward direction. So what is the difference between upward and vertical direction? So in a vertical direction, it is only following the straight line path, and in upward direction, the two coordinates are changing. When the object is going from this position to this position and then coming down, then in that case, it is the motion of object in a plane, and we know whenever the motion of object in a plane, then in that case, the two coordinates of the objects are changing there. The first one is the horizontal direction coordinate, and second one is the vertical direction coordinate. Okay, so in case of a vertical direction coordinate, if we consider, then in that case it is having the two coordinates in a vertical direction and the horizontal direction. Okay, so accordingly, if we draw its drawing, then we come to know that it's both the coordinates are changing. Suppose we throw an object in this direction. Okay, we throw an object in this direction, then what is happening there? What is happening here, that the object is following a projectile path, and this path of the object followed is known as the trajectory path. Okay, this is the trajectory profile which is followed by the object. This type of motion of object is the projectile motion, in which the object follows the trajectory path. Okay, so in this case, how much is the height of the object, or how much is the maximum height the object can attain, or for how much time the object will require to reach from this initial position to this final position. Okay, how much will be the velocity when the object will fall down on this ground surface. These all criteria we have to study, these all features we have to study in our projectile motion. Okay, so what is the projectile? In case of a projectile, when object is thrown in upward direction, but other than vertical, then object becomes projectile. And motion of object is the projectile motion. Okay. Motion of object is the projectile motion. Then in that case, the path followed by the projectile is known as the trajectory profile. Okay, so trajectory profile is the path followed during projectile motion. It is the path followed during the projectile motion. So, if we consider the object, and if we throw an object with some initial velocity u, then if we have to find out its components in a x direction and in a y direction, then we have to resolve that component into its, we have to resolve that velocity into its components. So in that case, what is necessary, that we must have to know this angle theta. So accordingly, if we give the angle theta, this is the initial velocity u, okay, and this is the angle made by the object with respect to the horizontal. And if we have to resolve this resultant velocity into its component, then we have to assume its component in the x direction and the y direction. Okay, so this is the component in the x direction, we can name it as the ux, and this is the component in the y direction, we can name it as the uy. Okay, we can name it as the ux, and second one is the uy. So if we want to write this velocity u, initial velocity u, then we can write it as the u is equal to ux plus uy. Okay, ux plus uy, and this is in terms of the vector. Okay, this is in terms of the vector. So in this case, if we study then how the ux and uy are given, how the components ux and uy are given. The ux is given as, from the diagram you can say that how the ux is given. This ux is given by its angle made with respect to the x direction. So ux is equal to u cos of theta. Okay, ux is equal to u cos of theta, and uy is equal to u sin of theta. Okay, uy is equal to u sin of theta. So in this case, we can represent these two vectors by using the its component ux and uy. Okay, and if we go for the magnitude, then we can write it as u is equal to u square is equal to ux square plus uy square. Okay, in terms of the magnitude, we can write out now the magnitude of u. Okay, in terms of vectors. Okay, so by this way we can find out the magnitude of u. Okay, now one thing we have to remember, that whenever the object in the projectile motion, it is having the two components, in one is the vertical direction and the another in the horizontal direction. But in that case also, if we find out in which component there is a change with respect to time, then we come to know that the velocity, the component of a velocity in a horizontal direction has the constant value. Okay, that is, the velocity along the horizontal direction is constant. That is, the velocity in the horizontal direction is a uniform, or we can say that the object is having the uniform velocity along the horizontal direction. Why? Because we know the acceleration due to gravity is acting in a vertically downward direction. Okay, the acceleration due to gravity is acting in a vertically downward direction, and when the object is following a horizontal path, then in that case there is no any effect of the acceleration due to gravity. And as there is no any effect on the object or the component of the velocity, then there is no application of the force there. And if there is no any application of the force, then we can say that velocity along the horizontal direction is the constant. Okay, so velocity along the horizontal direction is the constant. So we can say that the ux is constant throughout projectile. Okay, ux is constant throughout projectile, or we can say that it is the having uniform motion. Okay, it is having uniform motion. Now if we think about the second component of the velocity, that is the uy. So uy, it is the velocity component in a vertical direction. So if we think about the velocity component in a vertical direction, then we come to know that the velocity component is under the action of a acceleration due to gravity. Okay, it is under the action of a force due to the acceleration due to gravity. It is the motion of an object under the force of gravity. So in that case, as there is the application of a force on the velocity component, there is the accelerated motion in a vertical direction. Okay, so there is the accelerated motion in a vertical direction, and that's why we can say that component in a horizontal direction is having the uniform motion, and the component in a vertical direction is in a accelerated motion. Okay, so the uy, it is the under the force of gravity, so it is the accelerated motion. Okay, it is the accelerated motion. So uy is the motion of a velocity component in a which is under the force of gravity. So we can say that it is the accelerated motion. Okay, so if we draw this on this projectile or on this trajectory path, then we come to know that when we consider the motion of an object in a horizontal direction along any point of that trajectory path, then we come to know that at this point it becomes ux, at this point it is the ux, at this point it is the ux, at this point it is ux, at this point it is the ux. Okay, so value of the horizontal components remains the same throughout the projectile path. Okay, so value of the horizontal component is not changing as there is no any force acting on that component. But in case of a vertical component, if we see here, initially if we throw this ball with any object with a velocity of 20 meters per second, then if we consider here the uy, then it is uy, it will be suppose, and the combination of this will give us this path, and it is becomes equal to v is equal to suppose 20 meter per second. Then at this point, if we consider its component, then it is u is equal to v is equal to 10 meter per second. Then at this point, okay, at this point where it is achieving the maximum height, okay, it is achieving the maximum height, at this point we can say that there is no any vertical component, because at this point our velocity becomes 0. Okay, our velocity becomes 0. When we throw the object, it is thrown with the maximum velocity, so it is having the maximum velocity at the initial point, and as it travels in a vertical direction, its velocity goes on decreasing. Its velocity goes on decreasing. At this point it is 20 meters per second, at this point it is 10 meters per second. Then at the topmost point the velocity becomes 0. So we don't have to show this velocity component here, but the object is under the another component, that is the horizontal component, and at this point the horizontal component ux, that is the velocity component in the horizontal direction, becomes acting there. Okay, it will act there, and once it leaves its position from the topmost position and it starts its motion in a downward direction, then what will happen? The acceleration due to gravity will act on it. Okay, so acceleration due to gravity will act on it, and its motion goes on increasing, its velocity goes on increasing in a vertically downward direction. So if we show this here, it will be again the combination of both will give the v is equal to 10 meter per second. Okay, v is equal to 10 meter per second. Then again here, if we consider it is having the more velocity component, okay, it is having the more velocity component, combination of these two will give us the v is equal to 20 meter per second. Okay, it will give v is equal to 20 meter per second. So accordingly, if we see here why this velocity goes on increasing, because the force or the acceleration due to gravity acts on that object in a vertically downward direction, which increases its speed. Okay, which increases its speed, and here it is having the 0 velocity, and from this point its velocity goes on increasing again. So if we calculate any velocity, then in that case we know v is equal to u plus 80. So in that case, at here u is equal to 20 plus here a is equal to g, so value of g is there, and the time, that is the t, goes on increasing, the time period goes on increasing with respect to that, the calculation of g into t goes on increasing, and accordingly its velocity increases. Okay, so its velocity increases from this uppermost point to this downward direction, and when it is traveling from the bottom towards the uppermost point, its velocity goes on decreasing. So in this both case, what is important, that why it is following the trajectory path, why it is going in a trajectory path. The only phenomenon behind it, that it is under the effect of a gravitational force. Okay, it is under the effect of gravitational force, that's why it is having some force acting on it, and that's why its component along the y direction goes on changing as it is traveling in a under the effect of a gravitational force. So that's why it has to follow the trajectory path. Okay, so that's why we are getting the trajectory path of that particular motion of a projectile. Okay, and this type of motion of object is known as the projectile motion. If we think about the acceleration in a horizontal direction, then we come to know that as the velocity is constant there, as there is no any force acting along the horizontal component, then in that case the acceleration is 0. So in this case we can write down as, in this case here ux, the acceleration ax is equal to 0. In this case, along the horizontal component, the acceleration ax is equal to 0, and in case of a uy, we say that it is under the effect of a gravitational force, and that's why we have to say here that a is equal to minus g. Okay. Acceleration is equal to minus g because the motion of the object is in a opposite direction to that of the gravity. So that's why we have to consider a is equal to minus g there. Okay, because the object is going from the bottom position to the upper position, and in that case we can say that it is traveling against the force of gravity, and we have to take the value of g, the acceleration, as the negative. So in this all the motion, one thing we have to remember, that how much will be the distance covered by that object, or how much is the time required to cover that particular motion, or how much is the range. Range means how much is the distance that object can cover along the horizontal, that is known as the range. Okay, these features we will study in the next lecture, in the next part of this lecture. So in this, how much is the range of this object from the initial position to the final position, this horizontal distance is known as the range. So how much is the range of that object, how much is the horizontal distance that object can cover, or how much is the height that object can achieve, this maximum height that object can achieve. These all things are dependent on the three components. The first one is its initial velocity, the second one is by how much angle it is thrown from the floor. Okay, by this angle theta, how much is the value of this angle theta, and the acceleration due to gravity. Okay, so depending on these three factors, that is the initial velocity u, the angle made with the horizontal, that is the theta, and the acceleration due to gravity, depending on these three physical quantities, the projectile motion depends completely. Okay, so we have to see the features of the projectile motion, like its time period, how much time period that body is required to reach the final position, how much is the height the body can achieve, or how much is the range that object can cover. So all these features we have to study now in this lecture about the projectile motion.